Welcome, folks. Early joiners. We'll start right at noon. I really should have some waiting music for these. I could probably do that easily, but hey, Ray Porter. Welcome, Harry. Hello, everyone. All right, people are starting to load into the Zoom room here. We're going to get going in a few minutes. We had over 50 people signed up for this one, so it might take a little while. I really should get some waiting room music. For the next Lunch and Learn, I will do that. Hey, Paul. We got some utility folks joining us now. This is great. I'm just going to give it another minute or two. Really excited to hear from Bioforcetech again. Welcome, early joiners. We're just going to give it a couple minutes for folks to load into the Zoom room here before we get going. But happy Friday. It's a hot one, at least on the East Coast. Apparently it's cool on the West Coast where Valentino is.
Not here in San Francisco.
I think people are always surprised that the weather is cooler and foggier and not as sunny as
you know what's the crazy part, Jen, is that I'm here in South San Francisco now. I live in Redwood City, which is just 30 minutes south, and down is like 90 degrees. Here it's 58 degrees, just 30 minutes away. I'm like, how is it even possible?
It's the geography.
Yeah, but at least if you want to get some cold weather, you go to San Francisco. If you want to go down and have summer, then it's just 30 minutes away. So not too bad.
So this is early in the morning for you then, right?
Yeah, it's 9 a.m. Yeah, lunch time for you guys and breakfast time for us, which is fantastic. I ordered a great breakfast sandwich that will be here shortly after the presentation. So
yeah, and I feel like we should normalize the eating on camera thing. But
and the amazing part for me, coming back from Europe just last night, it's 6 p.m. for me. My body feels like it's 6 p.m., but it's 9 a.m.
All right, well, it's 12:01, so I don't want to wait too much longer. So why don't we get going here? Welcome everyone to our Lunch and Learn for webinar for July. It is hot, and so is this topic. So we've had quite a lot of interest in this particular Lunch and Learn, and I want to get right to it. But first, a few Zoom etiquette points. Everyone should be muted as you join the webinar. I ask you to remain on mute until the end of the presentation when I can open it up and you can personally ask your questions. There's also a question and answer in a chat function. I'll keep an eye on those. If you want to type in your questions as they come to you, that'd be great. This session is being recorded, and the link to the recording and slide presentation will be provided after the webinar to everyone who signed up. So thanks for joining us today to hear about what Bioforcetech's been up to since we last heard from them. Valentino Villa is with us today, as he was back in May 2020, when most of us first heard about this company, Bioforcetech, running a BioDrying and Pyrolysis facility in California. Last fall, Bioforcetech participated in NEBRA and NUIA's first Shark Tank event at our annual conference. They've sponsored our last student poster contest, and they've even done some work on our BEAM model. And I'm personally excited to hear about Bioforcetech 2.0, OurCarbon, which, by the way, is trademarked, and that's brilliant. So a little bit about our presenter today. Valentino is the co-founder and chief operating officer at Bioforcetech Corporation. He earned the status of Perito Industrial Capo Tecnico per l'Elettronica e le Telecomunicazioni, an Italian professional designation for an industrial expert in the field of engineering. And it's basically an industrial engineer outside of Italy. I hope I did that justice. Since
Amazing.
co-founding Bioforcetech, Valentino and his team have been rethinking every step of biosolids management to prepare for a carbon-free future. He believes that Bioforcetech's biochar, the OurCarbon product, is a resource, which is why he and his team are investing in research and development to expand the applications for biochar far beyond soil amendments. Valentino is joining us from California, where he lives with his wife and 2 sons. And it is great to have you back again, Valentino.
Thank you.
Let you take it away. I'll stop sharing my screen and you can take over.
All right, let's see if things work as before. Just to confirm. All right, awesome. Thank you, Jenny, so much for having me again after the 2022 Lunch and Learn. We've been in communication and working together, and I am very much a fan of the organization. And thank you so much for all the hard work that you guys are putting together, always on top of things. So thank you so much again for having me. Hello, everybody. My name is Valentino Villa. Again, I'm the co-founder and the Chief Operating Officer at Bioforcetech Corporation. I apologize in advance. My English may be a little bit rusty. I've been in Europe for 5 weeks. I just came back last night, so even jet lag is still on me. It feels like 6 p.m. for me, so please bear with me. I'll try to do my best, but I'm still a little bit jet lagged and in shock to come back to the US after 5 weeks of being in Europe, but it's great to be here. All right, so today's presentation will be focusing, of course, on the company, recent developments, but as well as going through the fundamentals and basics of our technology and showing some amazing developments that we've progressed on OurCarbon, the biochar product that we produce from municipal biosolids, and of course, discussing some of the latest testing and news on PFAS related issues. So beginning with the first, let's say, part of the presentation, just introducing the company for the ones of you who are not familiar with the Bioforcetech Corporation. So we are based in South San Francisco in California. We established the company in the United States in 2012. So it has been 10 plus years of us sort of pioneering the sustainable movements for biosolids and residual processing through sustainable drying and advanced pyrolysis systems. Our mission is very much to protect nature and human health, providing technologies that deliver a zero waste future. Very much our goal is to be able to transform organic waste and biosolids specifically into sustainable products. So if we look at today's situation in the United States specifically, of course, about 90% of biosolids and residuals are either disposed of in landfill or land applied for beneficial use of those biosolids. Again, about 90% are sent away utilizing those 2 methods. That's called a method. But we are seeing drastic changes in the industry, and especially for the future. And everybody's sort of scared of what's coming for new regulations, or how to best, provide solutions for wastewater treatment plants to be sustainable and, of course, complying with regulations, right? So we're seeing a landfill situation that has never been a great solution because, of course, landfills for organic waste, there's something better probably that can be done, but we're seeing drastic changes there too, right? So on the screen, you see some of the issues that we're facing nowadays between landfill and land application that, of course, we support as far as beneficial use to, benefit from the carbon sink of those biosolids and increasing the nutrients amount and making our soil healthier. But of course, there's some challenges related to that as well. So currently, at Bioforcetech, we do see waste, organic waste, of course, as a tremendous opportunity to resolve some of those issues that all of us are facing. So the main 5, let's say, solutions and goals that we want to have here through the sustainable processing of municipal biosolids are to be able to generate renewable energy from those biosolids, removing contaminants such as PFAS, PFOA, CECs in general, still sequestering that carbon that we all need to do something better, of course, for our planet, for the future generations to come. We're seeing some drastic effects nowadays. I mean, in Europe, just in Europe, the temperatures there were just out of control. Never in the history of Europe, I guess, there would be like such high temperatures, especially in Southern Europe, which, is definitely human related, right? So Still creating renewable products from those biosolids and organic waste. And last but not least, being able to divert as much as biosolids that we can from landfill disposal and benefiting from an in-house sustainable solution for beneficial products development and making. So the Bioforcetech system is a two-step process, right? So we position ourselves sort of at the end of the train for wastewater treatment plants after dewatering. So we deal and take care of the biosolids residue, and ideally our system is meant to be installed and positioned right after dewatering. So as close as possible to where the wastewater treatment plant produces the biosolid stream. Our system is able to accept the water sludge that can be digested or undigested with the minimum solids content of 17%. So generically speaking, any system such as a centrifuge, a bell filter press, a screw press should be able to allow our system to be efficient, sustainable, and taking care of your biosolids, again, in-house, ideally post-dewatering. So the first step of the process is our biological drying system that we call the BFT BioDryer, which is a non-conventional drying system simply because it does not focus on using just energy to dry biosolids that comes from the outside, of course, that energy. Our system has been designed and invented to being able to use biology as far as the main principle to being able to dry biosolids very quickly, very efficiently, and very reliably. So the BioDryer, the word says it, in the sense that it's a combination of utilizing biology and a very efficient system to utilize waste heat from the second machine. And the result is a very efficient system that is able to save a lot of energy compared to conventional drying systems and techniques. But the goal is still the same. Drying is to remove water from those biosolids that normally have a very high percent of the water. And so in order to be able to extract value producing products, removing CECs from those biosolids, we need to be able to dry those first. That's the reason why we developed the biodrying system, again, to be able to be efficient even during the drying portion. That older system require a lot of energy just to perform the first step of drying. So the purpose of biodrying, again, is to be able to removing water from the average 20% solids down to 70, 80, or 90% level of dryness, still being able to comply with Class A or EQ equivalent following the EPA 503. So again, just by doing biodrying, we're able to improve the quality of the biosolids that was, before the drying step. But of course, we have a second machine that is our advanced pyrolysis system that would be able to transform those dried biosolids into high quality OurCarbon biochar. The goal of the combined system, so between biodrying and the pyrolysis combined in a full train of equipment, is truly to stop producing waste. Again, going back to the mission of our company, we want to be able to deliver a zero waste future through sustainable methods and systems. So the combination of these two machines will allow wastewater treatment plants to stop producing waste, paying to get rid of waste, but finally producing resources and products in-house coming from municipal biosolids. The purpose of pyrolysis, again, that we recently discovered, I have to be honest, we didn't open the company in 2012 with the goal of removing CECs simply because we didn't know necessarily, but we understood that pyrolysis may be effective in also removing CECs such as PFAS, PFOA, microplastics, and so on. And I will have a few slides to show you our most recent developments and data that we collected throughout the past 3 to 4 years. Another great benefit of our combined system is to be able to deliver an energy neutral system from a thermal standpoint. So long as we have enough dryness from the biosolids stream that we will be starting with, the biodrying and the pyrolysis system combined may be able to achieve an energy neutrality system from a thermal standpoint. So again, no external heat should be necessary to perform the drying and the pyrolysis stages all across the full train of equipment dealing with the municipal biosolids. Last but not least, we want to produce sustainable products, right? So not just only sort of stop producing waste, but we want to make sure that everything that we produce in form of OurCarbon biochar can be sustainably utilized throughout the manufacturing or developments of sustainable and useful products. Our systems are modular and scalable, so we do pre-build, assemble, and pre-wire all of our technologies and systems at the manufacturing company, and our machines are delivered as a fully built system and skids in a row, right? So we have clients that may need one biodryer, two biodryers, 10 biodryers. It's the same machine that just gets installed as many times as is needed to get to the desired scale for processing train of the equipment. The sweet spot for implementation as far as biodrying and pyrolysis combined is between 1,000 to 15,000 wet tons per year. So again, it's a modular approach, it's a scalable approach. We have customers that are beginning with a partial installation and diversion, maybe covering and processing 40% of their biosolids production, and they will have capacity to scale and to increase capacity later on, adding more units to the current design without changing anything that has been done prior. So very easy for us to scale, to take a phased approach, and very much to not over-design systems for the next 30 years, whereas sometimes we really don't know what's going to happen 30 years from now. And also they can offset some of the capital investments to the later on years, so they can really take care of what's needed now with room to expand in the future, again, without changing anything that has been done prior. Looking a little bit more in details about the biodrying system, again, it's a non-conventional drying system and technique that utilizes biology, specifically bacteria, to being able to perform the first step of drying. Again, the system is able to work with digested or undigested water sludge, so long as we have a minimum of 17% dry solid. So we do require dewatering before our biodrying system. The system has been designed, again, to be modular and scalable in skid-mounted shapes, and you can see on the screen a sectional view of the unit, whereas nothing inside is going to be moving. There are no moving parts inside. It's just a big vessel where we load wet biosolids from the top, utilizing a shuttle screw conveyor. We load up to 8 wet tons per each batch, and the batch will be lasting from 50 to 72 hours, depending on the initial moisture content and the dryness that we need to achieve at the end of the cycle. The system utilizes and relies on mesophilic and thermophilic bacteria, depending on the process we want to carry on, together with a very efficient system to utilize waste heat, ideally from pyrolysis in form of hot water, again, to deliver an energy neutral system from a thermal standpoint, so long as we have pyrolysis after our biodrying system. Solids are loaded from the top and discharged from the bottom. So the dryer has the ability to rotate on itself, first to be able to mix the feedstock inside to achieve a right dryness all across the biosolids that has been introduced. And of course, to being able to allow the unit to discharge those dried biosolids from the same opening gate, just rotating the unit, depending on which position it has to be at. The resulting efficiency of our biodrying system is about 70% less energy compared to conventional drying systems and techniques, because again, we use a combination of bacteria activity through thermophilic and mesophilic, and with a combination of very efficiency for hot water recirculation that ideally comes from pyrolysis. I would like to say that we do not add anything to the biosolids that we process. We simply design the system to be rely on biology, almost like a compost process would do. So the air will start to be introduced inside the vessel. You will see a rapid raise in temperature from room temperature up to 150, 160 degrees Fahrenheit. And that is all controlled by the hardware and the software that we design together with the system. So again, there is no inoculation of bacteria. We just designed the system in order to promote life and utilize bacteria as much as possible, to be saving a lot of energy, of course, compared to other systems that require constant energy from the outside for the drying stage. It's a batch drying system and process, although it works on a 24/7 basis, up to 95% up running time. So it's rated for 8,500 hours per year with very low and simple maintenance. Again, the maximum temperature is around 150 degrees Fahrenheit, so around 63 degrees Celsius, whereas other systems may be doing the drying at 400 or 500 degrees Fahrenheit, with some concerns also for safety and other situations. This is a very simple system that everybody can run and operate in-house, again, with very low and simple maintenance tasks. Fully automated systems with very high-end technology for industrial automation. It's pretty much been developed as we go. We keep updating the system, the hardware and the software to bring newest updates. Like you have a car like a Tesla that you plug in and you receive constant updates. That's the same thing that we do with our machines. You'll be receiving updates on the software and making sure that things are up to speed with the highest great technology at all times. Again, just by doing biodrying, we're able to comply with 503, of course, EPA. We do meet time and temp to being able to get to Class A or EQ compliance, even from the biodrying stage as a first step. A few more information and data. One unit, again, I told you before, it's a modular and scalable approach, whereas we can have one unit as well as multiple units in line, depending on how much biosolids we need to process. A single biodryer has the average capacity of 1,000 wet tons per year, assuming 20% solid going in and 90% solids being discharged. Data on consumption, we have an electrical consumption that is between 25 and 35 kilowatt hour per each input ton, and the thermal consumption is between 0.9 to 1.3 million BTU per input ton. So extremely low, again, compared to conventional drying systems, very reliable and very efficient. The minimum solids, again, that we recommend is 17%, volatile matter, at least 45% on dry basis to make sure the biology will be able to do its magic and rely on bacteria to perform most of the drying part without using any energy from the outside. Since it's a batch system and very much fully automated with a lot of sensors and controls, we can very much tune up the desired dryness at the end of the drying system from 70 to 92% dry solids. So again, we can achieve Class A. Also, the vector reduction requirement, should we deal with undigested sludge, achieving the 90+% solids in order to comply again with Class A or EQ. Modular and scalable, skid mounted, so there's not much to be done on site once the units are delivered. Again, everything will be fully built and assembled and wired. The units just need to be positioned onto the cement pad, anchored down, and pretty much the system is ready to be operational already in a few days post-delivery on site. We deal with municipalities all across the country from east to west with many projects in the queue and developments. Of course, we comply with all the federal, state, and local regulations and requirements, and our units already come Class 2 ready following the NFPA 820 and other requirements that we need to, of course, comply with here in the United States. A few technical drawings here for the engineers that are on the call. So again, the biodryer is modular and scalable. It's comprised of 2 skids each unit. So the main skid having the reactor, motors, sensors, the catwalk for maintenance access, the screw conveyor, and we have the skid to the right or to the left. We can change configuration, of course, based on the best layout to be implemented on site. And that second skid has the blowers, the heat exchangers, the piping that makes a whole system between the combination of these 2 skids. Dimension-wise, each biodryer is 40 feet long, about 15 feet wide, and about 14 feet and a half tall, considering the highest point that is the catwalk, again, for maintenance access. So very compact, very well designed, and of course, we can go from 1 to how many units are needed, again, to increase and achieving the right processing scale for biosolids. I wanted to show some pictures of real installations and developments. This is our oldest installation in the United States, been operational since 2017 at Silicon Valley Clean Water in the San Francisco Bay Area. We have 3 biodryers being installed and deployed with room to expand up to 5 units. And that will happen hopefully next year, increasing some drying capacity. You can see how we connect multiple units. So of course, each unit will be running its own independent process, but the biosolid stream can be diverted between all of the units accordingly in order to optimize capacity and efficiency. So we will have a longer horizontal screw conveyor that will be distributing wet biosolids between the 3 units. And again, each unit will be running its own independent cycle. So you may have a unit 1 that is doing the final stage of the drying, Unit 2 that may be receiving some biosolids, and Unit 3 that is discharging some dry solids, right? So it very much depends on how we can best optimize capacity efficiency in order to make sure that the watering is always ready for BioDrying to receive cake, and so is the pyrolysis to receive dried biosolids. To the back of the screen, you see that tank, let's call it tank, that is a biofilter. So we, of course, provide also abatement devices that are suitable to achieve permit compliance, have no odors, and so on. Main two compounds as far as pollutants from BioDrying, dealing with municipal biosolids, are going to be ammonia and VOC. So any conventional system between scrubbers and biofilters should be able to achieve permit compliance and odor requirements. And we, again, are able to support and supply those together with our main train of equipment between BioDrying and pyrolysis. This is another installation that is located in Milano. I was just there last week. We have 7 biodryers, so we have a capacity of about 7,000 wet tons per year. It's an amazing installation inside an existing building and canopy. So the canopy that you see was already there. We just slided in biodryers one after the other, and everything was completed in just 4 days as far as receiving, positioning, anchoring, and pretty much it was a very quick turnaround for us, again, since we have a modular and scalable design with everything is pre-built at the factory. Another installation with 4 units, so 4,000 wet tons per year, another one with 2 units, and so on. So also what you can understand from these images are that our systems do require a flat cement pad and just a canopy to protect the equipment from UV, weather exposure, of course, so long as outside temperatures are not going, or dropping below 0 degrees Fahrenheit. That is sort of the limit of our technology as far as being outdoor, not really for the equipment per se, but mainly for the electrical components and parts. So long as we are not in extremely cold weather, we can be located outdoor with just a canopy, of course, for some cost savings for our customers that we support. This is a snapshot of our manufacturing facility located in northern Italy, nearby Milano. We've been doing manufacturing throughout our group of companies since the 50s. So we have a very wide network of suppliers, very high level of manufacturing with a beautiful 40,000 square feet warehouse that is able to produce up to 35 units per year. We're very busy nowadays fulfilling orders from Europe to North America. So our factory, I was there just a few days ago, was very, very busy and crowded with a lot of machines, which made me very, very happy. Switching to step number 2. So again, we talked and discussed about the BioDrying system that, again, is the first step of drying in order to get to a drier product suitable for advanced thermal equipment, right? So our second step is our advanced pyrolysis. And beginning with the definition of pyrolysis. So pyrolysis, for the ones of you who are not extremely familiar with that technology or that word, is a thermochemical decomposition of anorganic matter, so biosolids in our case, through the application of heat without the presence of any oxygen. So during the process, the main pyrolysis reaction, the system will be oxygen-free with temperatures anywhere from 900 to 1300 degrees Fahrenheit, so between 400 and 720 Celsius, in order to pretty much decompose the organic matter and producing high quality carbon that we call OurCarbon or biochar. The purpose of pyrolysis, again, is to truly much transform organic waste into fixed carbon. And from that product that we call OurCarbon, we're able to produce sustainable products that range from many different things and cool innovations that I will show you later on. I would like to point out that our system has been designed not to produce anything other than renewable energy in form of hot water that the drying system, of course, can benefit from, and high quality OurCarbon biochar. So there are no hydrocarbons, there is no tar, no oil that are produced from our system, just 2 products, OurCarbon and renewable hot water. So of course, the quality of our product, OurCarbon, is going to be the highest possible because it's going to be free from any condensation, from any contamination at that point, because of the way that we designed and manufacture our systems. Again, here we follow the same principle for modularity and scalability. So we have customers who have a single unit, as well as customers who will have multiple units in line, or that will be installing more and more units in order to increase capacity, to transform their biosolids into value. Permitting wise, it was pretty challenging back in 2015, being the first company trying to do something like this in a sustainable fashion and manner. Just simply there was no enough education back then because nobody else really did the same. So our journey started in 2015, working with US EPA, and finally about a year after receiving the approval for not being considered an incineration system and technology. So our systems have been approved by the US EPA to be a pyrolysis system, not an SSI. So nothing that requires incineration is applicable to our system, no Title V, no SSI requirements, so a much better and easier situation to be dealing with. Then, of course, we decided to start our journey, in San Francisco. And I have to be honest, we didn't know there was such a difficult place to do something like this. For the better, because we went through all the most difficult processing and permitting situation that we had to deal with. It took us about 3 years for the first plant to have full permitting, approval and compliance. But now we can proudly say that we were able to permit our first installation in the San Francisco Bay Area under the most stringent requirements in the United States, at least for air emissions. So fully approved at the end of 2018. Never had a permit violation since then. And of course, we are installing and developing more and more systems with a much easier permit situation. So now we are seeing about 2 to 4 months lead time as far as getting a full permit in place, because of course we collected a lot of data the past few years from stack testing to everything else that was required. So we can finally say that we can permit our technology pretty much in any jurisdiction in the US and Europe as well, since we went through already probably the most difficult thing to do back then. References. So since 2022 that we last did each other, we've had great success and a lot of more customers who have embraced our system. In the US, we have 8 installations in the queue, with 2 already in operation, and the other ones to be commissioned end of this year and in 2025, actually some in 2024. We were able to sell more than 25 BioDrying units and more than 6 pyrolysis plants between East and the western part of the US. Of course, there are many other projects in the queue in development that are not here on the map, simply because we have yet to receive orders and contracts from those customers. But there's a lot of activity and a lot of momentum, as you all can imagine, because everybody is seeking for sustainable solutions, especially related to PFAS, PFOA, but in general, just being sustainable and allowing us to live a better world, hopefully tomorrow. Another great market for us is Italy, my home country. I'm very proud to be having a lot of biodryers and pyrolysis systems down there as well. It's pushing very hard. The situation in Europe is semi-similar to the US, although with different challenges and situations. In Italy, the average disposal cost is very high, around 200 euros per each wet ton. So you can imagine, just by embracing, biodrying, just to be able to reduce the volume, the mass in a sustainable fashion while saving energy is already very beneficial for customers there that are paying, again, more than 200 euros per each wet ton. And that is just simply crazy, right? So we have a lot of customers that are embracing our solution. We are working with the government to, installing pyrolysis later on. Is slightly different than the US, but the next couple of years, we will see a rapid growth in Italy and Europe too for our systems combined. So we're very happy of this situation in Europe as well. Switching to OurCarbon, right? So as Janine said, we trademarked this beautiful name, I think 2-3 years ago. It's been registered, so we're very happy of that result. OurCarbon, we call it OurCarbon simply because it really is our waste, right? It's biosolids, our waste. It is our planet that at the end of the day, we need to deal with and face, that we need to make it a better world. So it is truly our carbon that we need to deal with here in a better way, right? So the concept is extremely straightforward, though sometimes it's challenging to execute. But we want to divert, right? Biosolids, especially from landfill disposal, we want to transform them and applying our carbon where it's needed the most, where it's the most value of that product. Being the first and still the only producers of OurCarbon, so biochar from municipal biosolids in the United States, it was definitely challenging for us to finding markets and applications because, again, really it was never been produced before. So the journey that we've entertained the past 5 to 6 years started from utilizing OurCarbon as a soil amendment. Of course, it comes from a biosolids product. Land application is something that is extremely beneficial, but finally we're able to still pursue that avenue, benefiting our soils in a better way, because we understood that our system, the pyrolysis step, is effective at removing CECs, PFAS, PFOA from the solids metrics, at least, that has been certified. So we can finally have a soil amendment product that is coming from biosolids that is finally cleaner, let's call it cleaner compared to before, right? So still benefiting from the carbon sink, benefiting soil in a very sustainable fashion and manner. So that was the first application that we developed, that we're still developing, that it's in use, although the past 3 years, we really started to look at OurCarbon as a new material, right? So when you deal with a new material, you have new applications, you have new properties. So we went back to square zero and like, okay, this is what we have. What are the best applications for this product? So we went through a lot of journey, a lot of testing applications, and we narrowed it down to an additional 2 avenues to utilize OurCarbon in a very sustainable and beneficial use. Concrete is one, pigmentation is the other. Together with soil amendment, so between pigmentation, concrete, and soil, we are able to offer guaranteed offtake agreements to all of our customers. So they will go from paying and going crazy as far as what to do with their biosolids and keep paying more and more and more every year, because everybody now is like, okay, pay 100, next year is 130. Well, we will be offering a free offtake agreement for the next 20 years. So there is nothing that will ever go to waste any longer. We will guarantee that every pound of OurCarbon that is produced, of course, so long as it meets the specs for quality and characterization, we will be placing it where it's needed the most between these 3 avenues. So again, we guarantee that pretty much tipping fees and waste will not be there any longer. We will be happy to manage the entire production of OurCarbon because, again, we have commercial applications that have been in development for a long time. Finally, they are real. So it doesn't matter the quantity, it doesn't matter what the plan is. Between these 3 avenues, we're able to entirely offtake the OurCarbon product that our customers will be producing in-house. Some amazing developments and updates. Unfortunately, Garrett is not here with me today. He's part of our OurCarbon team. He's been doing a tremendous job at developing all of these applications. But again, what we see being one of the best and more useful avenue for us to manage and utilizing OurCarbon is within concrete, right? So concrete, unfortunately, is extremely unsustainable. It's all the material that we produce the most as far as on our planet, and we've been producing it for so long, right? So definitely the concrete industry has seen some improvements as far as sustainability around how we made the concrete mixer, reducing dramatically the CO2 impact, but still it is something that is not extremely sustainable, right? So by incorporating a percentage of OurCarbon in the concrete mixer, we're able to dramatically reduce the carbon footprint, also making carbon neutral structural cement. So we have the ASTM in progress. It should be done in the next couple of months. It is rated at 3,200 PSI for structural grade concrete. And again, it's a very secure offtake for us. It doesn't matter the location. There's always been need of concrete and of course of OurCarbon to reducing the carbon footprint and increasing some of the properties of concrete as well. So great developments. We won a few awards recently with some of our commercial projects that we've done in Oregon with our partner there. And again, it's going amazingly well with a lot of exciting developments and announcements in the next few months. So stay tuned for more. We'll have some cool announcements to be shared. And as well as within the pigmentation world, we have a lot of applications in the queue, commercial agreements, and next year we'll be able to announce something extremely cool for the biosolids industry. Let's put it that way. You will see some cool stuff around between fashion and the design world. Connecting to one comment that Janine posted before, about 3 years ago, I think we truly wanted to understand the life cycle assessment and the carbon impact of our system. So of course, we worked with one of the probably most exponential company in the industry and following the BEAM model, truly to understand the carbon footprint and CO2 equivalent implication of the Bioforcetech system. So at the end of the day, we can say that every ton of our carbon produced is able to prevent up to 10 tons of CO2 equivalent compared to landfill disposal. We can increase this amount just by utilizing our carbon to offset some of the carbon, intensive materials such as carbon black and others. But comparing to the most typical avenues of, disposing of or applying biosolids, it seems that the Bioforcetech system is the most sustainable on a carbon footprint between the combination of biodrying and pyrolysis. Definitely better than landfill, but even compared to compost and land application, we're very close. And again, all we want to do is to be able to provide sustainable solutions for all of our customers in the markets that we serve. Switching to PFAS and PFOA. So our journey truly started in 2019. Again, we funded the company in 2012. We had a very strong mission that was we need to stop producing waste throughout the application of drying and advanced pyrolysis systems. But truly and honestly, we didn't know much about the additional contamination that might be found in biosolids. Not always, but sometimes, right? So in 2019, we wanted to understand more and to see if there was something we could have added to our system or provide, as far as being able to resolve this issue. And we performed the first testing in 2019 independently. So there were no, EPA, there were no, other stakeholders involved in the project. We just took the bait and just said, okay, let's analyze 38 compounds. It was already part of the list. We utilized certified labs here in California, and we took wet biosolids, dried biosolids, and the resulting OurCarbon from the same processing train of equipment. So out of 38 PFAS and the PFOA target that were analyzed, about 20 of them were found in the wet and the dry metrics for biosolids, but nothing was detected in the resulting OurCarbon biochar from those tests. So it was extremely encouraging for us. We were very happy to see those results, but of course we knew there were so much more that we just simply didn't know. So luckily in 2020, the EPA, of course, with the P team was looking for solutions to address this issue and problem. And we were the only company with an up and running system that was processing biosolids. I believe we still are. But so the EPA knocked at our door and say, hey, we're looking for technologies that could potentially destroy PFAS. Are you guys interested in doing some studies with us? And of course, it was a risky choice. But at the end of the day, all we want, again, is to be transparent, honest with ourselves, and just show data as they are, right? So we, of course, took the risk and said, let's work together. I think we have a great solution in hands, but hey, let's see what you guys think of that, right? So the main two questions were, can we eliminate PFAS from biosolids? And if so, where and how were they destroyed? So the test was conducted in August 2020, together again with EPA and us at one of our commercial sites. The list was expanded to 41 target PFAS compared to the 38 that were analyzed in 2019. We tested the BioDrying and the pyrolysis system, 6 1-hour tests. And of course, we analyzed the wet solids, the dried biosolids, the resulting OurCarbon, the scrubbing unit from the pyrolysis system, so the city tap water and the discharge scrubber water, and also stack analysis and air emission testing, utilizing a novel method. I would like to say that out loud because in 2020, the EPA was still understanding, still working on which method should we apply for this type of analysis. So our approach was to take a novel, method through FTIR and the canisters. All the equipment was PFAS-free, of course, guaranteed by the labs, but I had to say that, again, the testing method utilized was not the official one that now the EPA has in their books. So testing site, 3 biodryers and 1 pyrolysis here in Redwood City, California, and results for the solids metrics were very consistent with the results that we got back in 2019. So again, out of 41 target PFAS, they identified about 20 that were present in the wet and in the dried biosolid stream. But again, testing for OurCarbon came back with non-detectable levels all across the 41 target PFAS and compounds analyzed. So that was extremely amazing for us to see, again, being confirmed even with the EPA studies. And then, of course, we needed to understand more, right? So the results for analysis on the city tap water and the scrubber water were very consistent. So pretty much the city tap water had PFAS in there, and whatever concentration levels were in the city tap water were found at the discharge point post scrubber. So really nothing really was ending up there or created by the system or transformed. Levels going in were consistent with levels going out. Stack testing, that was the $1 million plus question that still we have to fully resolve. The results that we have received back from the study with EPA were a little bit inconsistent because, again, we applied another method to FTIR and canisters. So there were a weak observance of CF4 and C2F6 that might be related to residual concentration of dynamic spiking gases utilized. Because again, not consistent, since these results were not confirmed by the canister that showed none of the 17 analyzed fluorinated compounds above the detection limit of the instrument. So we believe we have a very great solution in hands, but we are aware there is still a lot to be discovered and still a lot that is unknown. I think there are more than 12,000 PFAS compounds, or something crazy that every day you keep changing, increasing or reducing. Like it's just so much more that we need to understand, that we want to understand, right? So again, I believe to date, our company as the one that has put, the face forward, producing the most amount of data and reliability out there. But we are very committed to understanding and finding out more. Indeed, we have new tests planned for end of 2023, beginning of 2024. Hopefully being able to solve, these outstanding questions, and everybody's wondering, are PFAS transformed? Are they destroyed? Do they end up in the stack? We think that we have the solution in hands, but again, we want to show and demonstrate things with, how real they are, right? So what we can conclude from the EPA testing is that the Bioforcetech system is effective at eliminating PFAS from biosolids and leaving no trace in the biochar product, OurCarbon. Small trace of PFAS were found in the scrubber water, but were comparable and the same as the city tap water. Definitely more exhaustive testing should be performed. Indeed, we are doing that. And we're very much looking forward to presenting new data, hopefully towards mid or end of 2024. We have a great team aligned, and I think something very exciting will be announced very soon in this regard. Last thing that I wanted to make sure I can share with you, the peer-reviewed article with the EPA study has been finally published in February 2022. I can easily share the link with you all, but it's publicly available. So for the ones of you who are interested to learn more and actually see the full article and data, it's available online. But otherwise, please let me know. I can share the link easily with you. So I hope I was not too long with my presentation, Janine, and I think we have some good time for a productive conversation here.
Yeah, no, that was perfect timing, I think. And yeah, we already have some questions. I have some questions. In this one, you might have already answered, Valentino. But the first question is, how are processed gases handled from the bio dryer? And I believe you were talking about VOCs and some of what comes out of there. But
yeah, I can answer that already. I mean, again, not a problem. So processed gases, we refer to the spent air, right? The fall air from the bio dryers. Again, dealing with municipal biosolids, but biosolids in general, we see as the two, let's say, pollutants, VOC and ammonia. We never have H2S because it's a fully aerobic process, so there is never the issue of H2S. So again, conventional systems and abatement devices such as a wet scrubber, a biofilter, or a combination of the two is effective and plenty. So depending on the installation, the type of sludge that we need to process, we will be ideally including and offering that solution that again is comprised of a wet scrubber, sometimes working with sulfuric acid, biofilter, or a combination of the two. So fairly easy and straightforward to being able to comply with permitting and have no orders from the BioDrying side.
all right, thank you. Here's a great question. Approximately what proportion of biochar or OurCarbon goes to the 3 different end uses right now?
That's a great question. That's a great question. So I would like to make the additional note that we have many systems that are in final, let's say, commissioning. We're still not producing like a crazy amount of OurCarbon, right? We're talking about a few hundred tons per year, right? About 500 tons per year that we're now producing every year. So the proportion it's now mainly going for concrete. So I would say concrete is about 80 to 90% of everything that we produce on a yearly basis. And it's also the most straightforward avenue for us to offtake the product that is also very beneficial. About 15%, considering 80% for concrete, is going for soil amendment, and about 5% for pigmentation. Pigmentation is the application that has the highest value per ton as far as monetary value, but the less use, because of course you need not much product.
Small amounts, yeah.
Exactly, to be producing, you know, food fashion line or like or glasses or like, you know, automotive parts and whatever. You very much need a very small amount. So that's the reason why.
Very interesting. And I'm sure those will change if you come back again in 3 years.
Yeah.
All right, here's another question. Could the carbon also be used in asphalt as well as concrete?
I believe so. We haven't invested much in asphalt simply because concrete is just a little bit more, I think, in use, and it's just a little bit of a higher end application, but I believe so. Again, we're focusing on concrete more than asphalt, but I think you can have the same result, honestly, there as far as carbon, you know, footprint reduction and benefit in the asphalt mixture.
All right, great. All right, another question from Christian. What is the temperature, residence time, and biochar yield of your units?
So that's a great question. I can easily answer the first part. The biochar yield very much depends on the feedstock mainly, right?
Sure.
So dealing with biosolids, because this is a biosolids presentation, and it's truly our bread and olive oil anyway, anyhow. The average temperature for our pyrolysis system is 1100 degrees Fahrenheit throughout the process reaction. That is about 620, 630 Celsius. Residence time is between 10 to 15 minutes. And biochar yield also depends on what type of sludge you have, digested or undigested, because of the ash content and the volatile matter that will affect the yield for biochar. But you go from 36 to 42% OurCarbon yield on dry basis. All right. So let's say you have a system that is processing 1,000 dry tons per year, then you may have between 380 to 420 tons of OurCarbon per year left. And that is, again, is on dry basis. The wet basis will be, much higher reduction, that is more than 90% on biosolids. With wood, for example, instead of the 36, 38 to 42%, you have an average of 22 to 24% yield on dry basis, right? So every feedstock is dramatically different as far as how much biochar you get out of the train of the equipment.
You sound like an operator. Do you guys actually operate these units, or or do you kind of turn them over to the wastewater treatment facilities to operate?
So we can do both, but ideally we hand it off to the wastewater treatment plant. Part of our, let's say, scope of service is also including training, startup, and commissioning. So ideally they will be running and operating these units, but we can also provide operating and maintenance services if they don't want to, take care of that in-house. But it's extremely easy for anybody to run and maintain these systems. I mean, you hear me talking. I've run, systems of 6 years. So I'm not, operator. I got no degrees on that, but it's very, very easy. Like my wife complains that I cannot fix a cabinet at home, but I can, I can operate this. So, it's like, she's like, how do you do it? Like, well, it's easy.
You make it easy, right? Here's another question. How much scrubber water is produced, and how is it being handled at the current facilities?
So I think that is referred to the pyrolysis system, right? So I take that as a yes. So how that is handled, it's connected to discharge water. So even the biodryers, about 1/3 of the water that is removed will be sent back to the headworks of the plant so they can clean it up and reintroduce it in the discharge. Nutrients or balances in general for the water that we give back to the wastewater treatment plant is not existing, because dilution is key, meaning that compared to the influent, the discharge water combined biodryers and pyrolysis is like 0.00001%. So really nothing changes for the wastewater treatment plant. The average, let's say, usage and discharge amount for the scrubber for the pyrolysis, I think is about 20 GPM on top of my mind. But of course, it changes between, how much sulfur you have in there, so the scrubber will be automatically adjusting based on the pH rating level. So it also depends on the sulfur level that you have in your biosolids, the type of biosolids, and of course, how much biosolids is fed to the system. But on an average, about 20 GPM.
Oh, thanks for giving that a shot. Appreciate. Here's another question. What is the approximate market value of OurCarbon in the 3 markets?
So let's put it away. It can go from lower 500 up to more than 5 figures, so per ton. So it very much depends on again uses, applications, quantities, and so on. But it's pretty amazing at the point that we were able to reach. And again, the value monetary wise, it is something that of course we care about, but not all of it. We care more about the sustainability aspect, how we can best utilize this product to benefit the circular economy model. And in any case, what we want for our customers is to be able to have a very reliable system in-house, not to be dependent from anybody else any longer, and stop paying to get rid of waste. That is our goal. If we can achieve that, anything on top of that as far as monetization comes after. So what we guarantee is that our clients will be paying no more to get rid of nothing. We will be happy to manage that for them. And of course, the more money we can make, the more money they can make too, because we also have profit sharing agreements with all of our partners. So
yeah, that's pretty good. All right, here's the last question from the crowd here. And yeah, I'm surprised as well, but the commenters, I'm surprised this is the only pyrolysis facility operating in the US since 2017 and no stack test results yet. What happened to the testing that was supposed to be done on the stack in March or April of this year? I don't know if this refers to your facility or not, but
I don't know that. So again, pyrolysis has been done for a long time, just not on biosolids, right? Biosolids is extremely difficult between the drying, because even drying is extremely difficult, but pyrolysis is another level, right? So the reason why there are no up and running facilities, because I think people and companies are still trying to figure it out what's the magic recipe to make it let's say reliable, because you can run a process for 1 day maybe with no issues, but I want to see the second day, the third day, the fourth day. That's the challenge, to have a very efficient system that does not require much human interaction, operating and maintenance, right? So that is what we are focusing on right now, how we can best provide and produce a system that does not need constant attention. That's what we want to get to, okay? We like simplicity. We like things that work very nicely, very efficiently, very smoothly. So again, if you ask somebody, can I have a pyrolysis system up and running for biosolids for 1 day? Yes, for sure. But the key is how to keep running, how to keep producing in a very efficient way, right? So I think there's still something missing from other parties or the industry in general, but we will get there. And I don't want to be pretentious. I don't want to be even the only company that does this. There's a tremendous need for sustainable solutions and systems. So the more, the better. I will be very happy in 3 years from now, there are 100 pyrolysis systems up and running, not just from my company, from other companies, because again, we need more sustainability around everything we do. As far as stack testing, 2017, 2015, 2016, we will deploy the first system. Again, PFAS, PFOA. I'm sure they were known, but nobody really required, testing, analysis, data. I mean, the EPA didn't have an official testing method, right? So we did everything that we could, that we had to do in order to, comply, oblige, and show data. We did testing with EPA in 2020, voluntary testing, because again, it was not required. Still, it is not required. What I can tell you is that we're doing everything we can. We have our best effort put forward to do, again, the most amount of testing, collect the most amount of data, be as transparent as possible, and finally showing results and hopefully resolving some of the missing data and gaps that we all have, right? So if you ask even your most loyal engineer what happens to PFAS, PFOA through pyrolysis, they will have an answer. Is there a defined answer? No, because again, we are working very, very hard on it. Not just me, but thousands, if not millions of people all across the world.
Thank goodness.
So that's what I can tell you.
All right. Let me see. All right. And that does seem to wrap up the questions from the crowd here. And I don't really have any others. You were kind of answering them as we went along. I don't know if there's any last thing you want to add, but we are approaching the end of the hour. So
yeah, no, I hope you enjoyed your lunch. I will enjoy my breakfast. And no, I wanted to thank you so much for having me, for inviting me. And again, next year, I hope we'll be able to do the same. We'll have cool announcements, amazing announcements next year. We're working on a lot of exciting things. So again, stay tuned for more. I appreciate your time. Thanks for joining today. Any follow-up questions, of course, it's welcome either through Janine or myself directly. You can see some of the contact information on the screen, and we look forward to being able to serve your community as the best that we can. So thank you again.
And I may follow up with some questions for you, but yeah, thank you so much, Valentino, and really best wishes for Bioforcetech's continued success treating biosolids. And thanks to everyone for joining us today. The next Lunch and Learn in August, you'll hear from yet another Shark Tank participant, CECs Energy, and I'll send out some more information on that soon. And we have these lined up through October, so please check our events page and let me know if there's something you want to lunch and learn about. I'll try and make that happen. All right, thanks everyone. Have a terrific Friday. Happy weekend.